Our planet's story begins over 4.5 billion years ago. Imagine a vast cloud of cosmic dust and gas. This cloud, a nebula, was the birthplace of our solar system. Gravity pulled this matter together. It swirled faster and faster. The center ignited, forming our sun. Around this newborn star, dust and gas collided. These collisions created larger and larger clumps. Eventually, these clumps grew into planets, including our own Earth. The early Earth was a violent and chaotic place. Molten rock covered its surface. Asteroids and comets bombarded the young planet. These impacts generated immense heat, keeping Earth in a molten state. Volcanoes erupted, spewing lava and gases into the atmosphere. This early atmosphere was very different from the one we breathe today. It had little oxygen and was toxic to life as we know it. Despite the chaos, the seeds of life were already being sown. Within the swirling dust clouds and fiery impacts, complex molecules began to form. These molecules, the building blocks of life, would eventually give rise to the first organisms. The journey from a molten, lifeless rock to a planet teeming with life is a story of extraordinary transformations. The early Earth's atmosphere was a far cry from the air we breathe today. It was a toxic mix of gases like methane, ammonia, and carbon dioxide. Oxygen, essential for most life today, was almost non-existent. This lack of oxygen meant there was no protective ozone layer. Harmful ultraviolet radiation from the sun bombarded the Earth's surface. This radiation would have been lethal to most modern life forms. However, this seemingly hostile environment was not entirely inhospitable. The very gases that made the atmosphere toxic also held the potential for life. Methane and ammonia are rich in hydrogen, a key element in organic molecules. Energy from lightning strikes and volcanic eruptions could have provided the spark needed to transform these simple gases into more complex compounds. These compounds, in turn, could have assembled into the precursors of life. While the lack of oxygen presented a challenge, it also provided an opportunity. In the absence of oxygen, certain chemical reactions could occur that are impossible in our oxygen-rich environment today. These reactions, driven by energy from the environment, may have played a crucial role in the origin of life. Thus, the early Earth, while seemingly inhospitable, possessed the raw materials and energy sources necessary for life to emerge. The molten Earth began to cool. As temperatures dropped, water vapor in the atmosphere condensed. Torrential rains lashed the planet's surface for millennia. These rains filled the first oceans. The formation of oceans was a pivotal event in Earth's history. Water provided a stable environment for complex molecules to interact. It acted as a solvent, allowing molecules to move and collide, facilitating chemical reactions. These early oceans were far from tranquil. Volcanic eruptions continued to spew gases and molten rock into the water. Asteroids and comets still bombarded the planet, some impacting the oceans with tremendous force. These events, while cataclysmic, may have also played a role in the origin of life. They delivered organic molecules and minerals to the oceans, enriching the primordial soup. Furthermore, hydrothermal vents, fissures in the ocean floor spewing hot, mineral-rich water, likely existed in these early oceans. These vents could have provided the energy and chemical building blocks necessary for life to arise. The presence of liquid water on Earth is what sets our planet apart. It is this unique feature that allowed life to emerge and flourish. As we explore other planets and moons, the search for liquid water remains a key focus. The presence of water, especially liquid water, is considered a strong indicator of the potential for life beyond Earth. The exact moment when non-living matter transformed into life remains one of science's greatest mysteries. However, we know that the early oceans played a crucial role. Within this primordial soup, rich in organic molecules, life arose from non-life. This transition from simple molecules to self-replicating entities is a testament to the power of self-organization and natural selection. One leading hypothesis suggests that RNA, a molecule similar to DNA, played a key role. RNA can store genetic information like DNA, but it can also catalyze chemical reactions. In the primordial soup, RNA molecules might have self-replicated and evolved, eventually giving rise to more complex forms of life. Another hypothesis focuses on the formation of simple membranes. These membranes, formed from fatty acids, could have enclosed self-replicating molecules, creating the first protocells. These protocells, though primitive, would have been distinct entities separated from their surroundings. The emergence of life was a pivotal event in Earth's history. It marked the beginning of a new era, one where life would shape the planet and its destiny. Understanding how life arose from non-life is not only a scientific endeavor but also a philosophical one, prompting us to contemplate the very nature of life itself. The early life forms were simple single-celled organisms. They thrived in the oxygen-free environment, obtaining energy from the chemicals surrounding them. However, around 3 billion years ago, a new kind of life emerged, cyanobacteria. These bacteria possessed a remarkable ability. They could perform photosynthesis. Photosynthesis uses sunlight to convert carbon dioxide and water into sugar, releasing oxygen as a byproduct. The advent of photosynthesis had a profound impact on Earth's atmosphere. As cyanobacteria thrived, they released increasing amounts of oxygen. This oxygen, initially toxic to many life forms, gradually accumulated in the atmosphere. This great oxidation event was a turning point in Earth's history. It paved the way for the evolution of oxygen-breathing organisms, ultimately leading to the diversity of life we see today. Oxygen also played a crucial role in shaping Earth's climate. It reacted with methane, a potent greenhouse gas, removing it from the atmosphere. This removal of methane likely triggered a global cooling event, leading to the first widespread glaciations. These glaciations, in turn, would have had a profound impact on the evolution of life, driving further diversification. Section 6. An explosion of life. For billions of years, life on Earth remained relatively simple, consisting mostly of single-celled organisms. Then, about 540 million years ago, something extraordinary happened. Life diversified at an unprecedented rate. This event, known as the Cambrian Explosion, marked a turning point in the history of life on Earth. Over a relatively short period, perhaps as little as 10 million years, a dazzling array of new life forms appeared. These creatures were unlike anything that had come before. They had new body plans, new senses, and new ways of interacting with their environment. The Cambrian Explosion saw the emergence of most of the major animal groups we know today, including arthropods, mollusks, and chordates, the group that includes vertebrates like ourselves. The causes of the Cambrian Explosion are still debated, but several factors likely contributed. The increase in atmospheric oxygen provided more energy for larger, more complex organisms. The evolution of new genes allowed for greater diversity in body plans. Additionally, changes in ocean chemistry and the availability of nutrients may have created favorable conditions for the rapid evolution of new species. Section 7. From chaos to complexity, the Cambrian Explosion was just the beginning. Over millions of years, life continued to evolve and diversify, filling every niche on Earth. From the depths of the oceans to the highest mountains, life found a way to thrive. Plants colonized the land, followed by animals. New ecosystems emerged, each with its own unique web of life. Extinction events, some catastrophic, punctuated the history of life, yet life persevered, each time rebuilding and evolving into new forms. The journey from the primordial soup to the complex biosphere we see today is a testament to the power of evolution. Through the processes of natural selection and adaptation, life has transformed our planet. Earth's atmosphere, its climate, its very geology bear the imprint of life. The story of life on Earth is not just a tale of survival, but one of innovation, adaptation, and remarkable resilience. From the simplest single-celled organisms to the complexity of the human brain, life has continually pushed the boundaries of what is possible. Section 8, a delicate balance. Today, Earth teems with a staggering diversity of life. Millions of species inhabit our planet, each playing a unique role in the intricate web of life. This biodiversity is not only beautiful, but also essential for the health of our planet. Ecosystems depend on the complex interactions between species. These interactions regulate our climate, purify our water, and provide us with food and resources. However, this delicate balance is under threat. Human activities are driving habitat loss, climate change, and pollution, pushing countless species towards extinction. We are witnessing the sixth mass extinction, a rapid decline in biodiversity driven by human actions. This loss of biodiversity threatens the very systems that sustain us. Preserving Earth's biodiversity is not just an ethical obligation, but a necessity for our own survival. We are part of this web of life, intrinsically connected to the fate of other species. By understanding the history of life on Earth, we can gain a deeper appreciation for the preciousness and fragility of our planet. We must act now to protect the diversity of life on Earth for ourselves and for future generations. And Section 9, Reflections on a Blue Planet. As we reflect on the journey of life on Earth from its humble beginnings to its current splendor, we are filled with awe and wonder. From the violence of Earth's formation to the emergence of the first cells, from the rise of oxygen to the explosion of life in the Cambrian, Earth's story is one of constant change and remarkable resilience. Our planet is unique in our solar system, a blue oasis teeming with life. Understanding the origins of life on Earth allows us to appreciate our place in the universe. It reminds us that we are not separate from nature, but a part of it, products of the same forces that gave rise to the first living organisms. As we explore other planets and search for signs of life beyond Earth, the story of our own planet serves as a guide. It reminds us that life, once thought to be rare and precious, has the potential to arise in the most unexpected of places. The journey of life on Earth is far from over. New challenges and opportunities await. It is up to us, the current stewards of this planet, to learn from the past, protect the present, and ensure a vibrant future for all life on Earth. Let us strive to be worthy inheritors of this incredible legacy, ensuring that life continues to flourish on our planet for billions of years to come.